Hello viewers, this is Biswajit and you are watching Curiosity Squared. Here we're gonna look at a nice little geometry problem. It says a hexagon has all congruent interior angles and consecutive sides of length 5, 3, 6 and 7. Then our goal is to find the length of the remaining two sides. And this problem came in Italian Mathematical Olympiad, which was given in the year 2001. And the reason behind choosing this problem is that this problem is built on a 7th or 8th standard concept from our regular textbooks. Even a student from 7th or 8th standard can able to understand the concepts behind this problem, although it appeared in a national level Olympiad exam. So before we go into the full solution, let me give you guys some hints to try this problem out a little bit. So here is my first hint. What is the angle sum of a hexagon? There is a standard formula that allows you to write down the sum of the interior angles of a n-gon in terms of n. That is n minus 2 times 180 degrees. You should keep this in mind whenever you are working on geometry problems involving polygons on this kind of competitions. And my next hint is to think outside of the hexagon. So whenever you are working on this type of geometry problems, you often have to construct extra points from the ones given to you. And you can do that outside of the figure or inside of the figure or both. So to think, it will be most useful in this case to construct some points outside of the hexagon. So keeping these points in mind, give this problem a try, and whenever you are ready, keep watching the video to learn how to solve this problem. So hopefully those hints were helpful, and now we are ready to look for a solution. So first of all, I have drawn a diagram. So notice I have got this hexagon with vertices A, B, C, D, E and F. And then I made my side lengths 5, 3, 6 and 7. So those are the lengths in the given order, and then the unknown lengths Y and X. Then furthermore, we know all of these angles are congruent. Then previously we know that the sum of all the interior angles of a hexagon is 720 degrees, which you can calculate from the standard formula for any kind of polygon you see. But the fact that each of these angles are congruent tells us that each of these angles has angle measure 720 divided by 6, that is 120 degrees. So I will just go ahead and level those angles as 120 degrees in our diagram. That's actually gonna be helpful. Now we're gonna use our second hint, which was to think outside of this hexagon. Or in other words, we are going to put some points outside of the hexagon that will be useful as we move forward. So here I am gonna extend this line segment FA in A direction, and similarly we extend the segment CB in B direction. And let's name this intersection point as X. Looks great. Now we are gonna do same kind of thing all over this picture. So we will extend side BC in C direction also. And here we will extend ED in the D direction. So let's go ahead and call this vertex as Y. Then we will do the same thing of here as well. So here we will extend this and we will extend this, and we will call this new intersection point as Z. So we are halfway done. Now here is a really important thing. Notice that the angle ABX is supplementary to angle ABC, because that makes a straight line. As this is 120, so that's going to make this equal to 60 degrees. But we can say the same thing about angle FAB and angle BAX, as those are supplementary, which makes this 60 degrees and also makes this 60 degrees by the angle sum property of the triangle. So that means this triangle right here is an equilateral triangle. As AB measures 5, so the remaining two sides of this triangle ABX should have length of 5. Now we can play the same game over here and notice that angle BCD and DCY are supplementary. This is 120. So that makes this angle 60 degree. And angle CDY is also 60 degree. Kind of playing the same game over on that side. And finally this remaining angle is 60 degree as well. Again, the angle sum property of the triangle. We know the length of this side DC is 6. So that gonna make these last two side lengths also 6. Fantastic. But now the same kind of things work exactly in this remaining triangle FZE up here. But it has a side length of Y which is unknown. But that means we have got two sides of lengths Y. Now notice here we have got this large enveloping triangle around the whole thing. That is triangle XYZ. And we know that each of these corner angles is 60 degrees, which we have determined earlier. So that makes us conclude this triangle XYZ is equilateral. But now that's going to give us a system of equations corresponding to the side length. So if it is equilateral, then all the side lengths are the same. So now we equate the sides for the triangle XYZ. So the side XY has to be equal with the side length of YZ as well as the side length of ZX. Notice that XY has side length of 5 plus 3 plus 6, so that's equal to 14. Then YZ has side length of 13 plus Y, so we can write that as 13 plus Y equals 14, which implies Y equal to 1. Then XZ has side length of 5 plus X plus Y, and we can equate it with 14. So 5 plus X plus Y equals 14. As our Y equal to 1, then we can solve for X and get X equal to 8. So that's our final answer to this problem. Incredible. We all solved this by using only school level geometry. Thanks for watching. Please subscribe to my channel. I make videos on math and logical puzzles. If you like this video, then check out other videos of this channel. There are a bunch of more interesting puzzles out there. And stay tuned for more such problems. So in the end, here comes You Feature Me, I Feature You segment. And this announcement is for 11th and 12th standard students that if you are looking for a top class chemistry content for boards or competitive exams without any distraction, then I have an awesome suggestion for you guys. Please check out the video description for more details. And yes, thank me later.